So without further ado, I would like to basically give some introduction about our speakers. I will be inviting Dr. Abdulla Qaban, who is basically a research fellow and project manager in sustainable innovation at London South Bank University. He is basically leading and conducting research and development projects to support SMEs in developing sustainable products, services under the Sustainable Innovation Program. This is funded by the European Regional Development Fund. Dr. Abdulla Qaban, he has received his bachelor's from the University of Surrey and his master's in mechanical engineering from the Tacit University. He received his PhD in mechanical engineering from the City University of London. His PhD was focused on the effect of alloying composition and cooling rate on hooked ductility of TWIP steel, twinning induced plasticity steel, and the mechanical properties of high-strength low-alloy steel. The project was supported by steel makers Tata Steel in the UK and POSCO in South Korea. He has also held the visiting lecturer position at the School of Mathematics, Computer Science and Engineering at the City University of London. Dr. Abdullah Qaban's research lies in the area of material science, engineering, manufacturing, production, processing, materials characterization, mechanical properties, electrochemical corrosion behavior of materials, along with current sustainability towards SDG goals. So without further ado, I would like to invite Dr. Abdullah Qaban to proceed with his speech on his topic, Sustainable Innovation Program to Support Startup Company Systems.
Thank you, Dr. Main, for the introduction, and thank you for inviting me for this event. And I would have the great thank you. So thank you again for inviting me for this event. As the work we are actually doing is more international, so it would be very good to share some of the projects that we have done with different startup companies in different areas in the world. Some of them are in the UK, and some of them are international companies with, with different sectors. So under sustainable innovation, we are not actually focusing on a specific sector. We look at SMEs from the built environment, from the renewable energy, and even we did work with SMEs in the electric vehicles. So I'll give you an overview of my presentation. Sorry, I think my screen is freezing for some reason. Yes. So in this presentation, I'll be covering or giving you some introduction about sustainable innovation. And then I will follow this up by 5 case studies, 5 companies. So actually, we did deliver a good number of projects under sustainable innovation. I believe we are looking at 200 projects that we have delivered so far since the launch of sustainable innovation 3 years ago. But I'll be focusing on startup companies that I did personally lead, and the projects that I have conducted since I have started sustainable innovation around 1 year and a half. So just telling you more about sustainable innovation, where we are getting the funding from, what is the nature of our activities, and how we actually support small and medium enterprises, SMEs. So sustainable innovation is a program that aims to develop new technologies that are sustainable and also that improve our life. So reducing the emission, improving people's health. So it is any project or any idea that can make our environment better. And we have received a funding of £4 million from the European Regional Development Fund to tackle barriers to innovation by providing the best research and development support to SMEs. The way we support SMEs, I would include 3 main areas on how we support startup companies. Firstly, we connect these companies with London South Bank University academics and expertise in various sectors. So, as I have mentioned, sustainable innovation, although I'm personally from the School of the Built Environment and Architecture, but we do have academics from other schools like the mechanical engineering and energy and material science and so on. So once we receive an application from a company, we do go over the application and we see what area of support they are looking for. And based on that, we connect this company to the right academic to get the support in that particular area. And I can give you one nice example. We had an application from a company to develop solar panel with a tracking system. So as you know, solar panel is fixed, right? But the sun is not fixed. The sun is moving. So the idea was to incorporate tracking device, which is a motor, in order to move the solar panel with the movement of the sun in order to get the maximum amount of light and to generate the maximum amount of electricity. However, the CEO was or had a computer science background, so we needed to ensure that he get the expertise in the renewable energy sector and also in the mechanical design, as we had to design the system from scratch. The other area of support we provide is access to equipment, software, and facilities in general. Some of the SMEs, they already have the knowledge, they already have the expertise, they know what they are doing, but they don't have funding. They want to, to characterize or to test the new material that they invented. So what we do, we support them by giving them all the resources, all the London South Bank University facilities and equipment that they can be using to progress further with their project. And if they want to use a software simulation as well, this is available. And if we don't have some of the equipment that is required by the SME, we do have funding for each project. So we can buy consumables and equipment. We can also hire some of the equipment in other universities and research centers to enable them to conduct this particular experiment. And finally, we have the research and development subsidized. So this is only available for advanced SMEs. So if we feel that this SME has a brilliant idea, something very innovative, we provide them with we help them to hire someone specialized in that area, and South Bank University will pay 40% of the salary for 1 year as a research and development support. So going into the case studies of some of our projects, I'm starting with a company called Pioneers, who are specialized in sustainable construction in Gambia. So the problem with Gambia, especially rural areas, they have very basic building materials. So not thinking of concrete and cement and this sort of things. So the materials they are using are very, very basic, and it doesn't meet the requirements and the necessary demands for long-term building. So for example, in some of the weather conditions, like when they have rain, storm, and wind, their houses are destroyed, especially talking about the rural areas in Gambia, and they have to keep rebuilding and rebuilding their houses. So Pioneers came to us, and they wanted our support in order to give them a kind of advice, recommendations, what would be the best materials they could use in Gambia. Of course, in South Bank University, we are in the UK, we may not have enough knowledge about the built environment in Gambia. So we did some literature review on the most common materials that are available in Gambia. We mainly actually looked at natural materials like coconut and very natural materials because our aim was not only to have a stable building, but also to have something which is sustainable, because we are sustainable innovation. So we wanted to ensure that we have a housing unit that has low carbon emission to the environment. And based on the research that we have done, we found out, and based also on the data we collected from the Gambian environment, we found out that straw bale was the most reasonable material to be used for the built environment in Gambia for I would say for 3 reasons. The first reason is that straw bale is highly available in Gambia. It is available almost, everywhere. Wherever you go, you will have the straw bale. And the problem there that most of the straw bale, because its availability exceeds the demand, most of these straw bales are, they are burned, right? And when they burn it, the impact or the negative impacts will have on the environment and on people health. So we said, why don't we actually take this straw bale, first of all, use it for the built environment, and in the same time reduce the emissions that are caused by burning these straw bales. And when we did further research on straw bale, because one of the interesting facts that in the UK we don't use straw bale to make buildings is that we don't have a clear standard. How do you do the testing? How do you know if the straw bale is a suitable material for the built environment? So we did further research, we did some data collection, and also we did some testing, as you can see here. So what we did, you can see 3 pictures on the left. So simply what we did, the difference that we did test the compressive load in different orientations. So on the height, width, and the length, to see how the orientation would affect the load resistance of the straw bale. And we also picked one of the straw bales which was tested at the height, because as you can see in the photo here, this is comparing the load resistance with the deflection, and you can see the straw bale which was tested at the height orientation gave the highest load resistance. I'm talking about 60 kilonewton in comparison with around 38 kilonewton for the width and almost 5 kilonewton throughout the length. So we picked up this one and we did some plastering of the surface to see how the plastering will enhance the strength further. And as you can see here, the strength went up all the way to over 140 kilonewton. So this project was one of the probably most impactful project in the built environment. And after the project, the company went to actually start to commercialize the straw bale in order to to be used for the built environment. And also one of the advantages, I would say, that increasing employment. Now, when we talk about straw bale is available everywhere in Gambia. So you don't really have to have a factory in the capital and then you go to the factory in order to make the materials and then take it to the cities. No, it is on-site production where you can have the on-site production and you can also increase the labor in the rural areas as well. The other project was with MEMA. So MEMA is specialized in solar power in Sudan. So I'm moving from Gambia to Sudan, but we are still in Africa. Now, Sudan also has a problem with the electricity supply, but in the same time, Sudan had the right conditions. They have the right environment for the solar system. So this project aimed in order to, one of the problems that they didn't do any research, they don't have much information, because normally solar power system, feasibility will depend on the location, right? So if it works in a country like the UK, it doesn't mean it will work in Sudan, right? So they have done no research in the past, and we had to do some experiment to ensure that the solar power system is suitable for the Sudanese environment. 2 of the main parameters that we consider when we talk about the environmental conditions and how they affect the solar power output is temperature and humidity. These 2 are the most important parameters. So what we have done here, we have collected the data on the temperature and the humidity throughout the year in Sudan and also throughout the day. So from the morning until midnight to see what actually are the temperature and humidity in the Sudani environment. Now, the other challenge, in order for us to test the solar panel in the Sudani environmental conditions or the weather conditions. Do we actually have to go all the way to Sudan, install the solar panel and test it there? The answer is no, because in London South Bank University, we have the environmental chamber. So it is a room with around 6 by 4 meter. And what we can do in the environmental chamber, we can adjust the temperature, we can adjust the humidity to the level that can simulate the weather conditions in Sudan. And as you can see in the picture here, you can see me as the CEO of MENA, and Mubarak, who is the PhD candidate. And we have the solar panel in front of the what we call the artificial sun. So this will simulate the sunlight. And you may notice that the solar panel has some dust on it. And we did that in purpose to simulate the dust impact on the solar power output. And I'm sharing some of the results that we have found. So on the left, you can actually see, first of all, this is for the period from January to April. And here you can see the temperature. So the temperature in the afternoon, in the evening, and the morning. You can see the temperature in the afternoon can reach around 35 degrees and drops to 20 degrees in the morning. And we try to connect or correlate that to the system output. So in the next one, you will see the panel temperature. So this is the weather temperature, and this is the panel or the solar panel temperature. And you can clearly see that in the afternoon, you will have the highest panel temperature around 80 degrees until the morning one, which drops to 60 degrees, which is expected because you have less or lower temperature. But the interesting fact here in the bottom, you see the open circuit voltage. Now we use the open circuit voltage in order to understand the power output. So the higher the voltage, the higher the system, or the higher the power is coming from the system. And you can clearly see as the temperature of the panel drops, the open circuit voltage will go up. So we're talking about around 19.2 voltage in the morning, which drops to around 17.7 volt in the afternoon. So this shows a very clear relationship between the temperature and the system output. So the system efficiency increases as the temperature goes down. One also more interesting thing that we simulated the rain. So when we have a rain, is that going to increase or reduce the system output? And as you can see here, this is the dry condition where we have the lowest voltage, 17.5. But as we have the rain condition, you can see that the voltage increases. And this is also correlated to the panel temperature. These are the panel temperatures, which also will drop because of the rain. And this is the wet conditions. So simply, as the time passes, so as we leave the panel for longer after the rain, that will reduce the temperature further, and this will increase the power output of the system. One other thing we looked at is the shade position. Now, how do we position the solar power? Assuming I'm living in a city where you have lots of towers and buildings, can we put the solar panel in a location where we have lots of buildings? So what we did here, you can see this no shade. This is when we have the solar panel where we have nothing obstructing the sunlight to reach the solar panel, which we got around 18 volt. But as we cover some of the areas, so when we cover the middle cells of the solar panel, the voltage will decrease by around 50%. So from 18 to around 9 volt. But it is interesting to say that actually when we cover the corner of the solar panel, the effect is even worse because the volt or the voltage will decrease by around 90%. And this actually indicates that the solar panels has to be positioned in a place where there is nothing to obstruct the sunlight from reaching the solar panel. Another project in hybrid energy solution in sub-Saharan Africa. So this project, one of the interesting facts about sub-Saharan Africa that it has the highest population growth in the world. And at the same time, it has the lowest electricity supply in the world. So you can see the big gap we have here. So with this project, we tried to find a solution, how we can, help the population in sub-Saharan Africa, especially in rural areas, to get access to electricity, especially the areas where they are off grid. And the suggestion here was to use hybrid energy system. So hybrid energy system will consist of the solar panel and the wind turbine. Okay, as we believe that incorporating both systems in the right location will enable us to get the power that we need to feed the electricity in these areas. So what we have done in this project, we scanned the entire sub-Saharan Africa. We collected the data. So when I talk about sub-Saharan Africa, I'm talking about 42 countries. It's a very big region. And we looked at the regions which probably would have the highest PV potential for the solar system and the highest wind speed for the wind turbine. And I'm just showing you an example here for Somalia. So if you look at Somalia, you can see here that the north side of Somalia has the highest PV power potential in this area here, as you can see in red, while the south will have much lower potential. And also when you look at the wind speed, for the same country, you will also notice that the highest wind speed will be available in the north of the country, especially the northeast, and also some areas in the northwest. So what we were trying to do here, we're trying to find locations which combine both. So we selected the north of Somalia in order for us to do further research on the hybrid system, as we believe that this area will have the best power output. Normally, for example, for wind energy, we need at least 3 meters per second for the wind turbine to rotate. But actually in the north region, we found areas where we have around 7 meters per second, so almost twice what we need. And we did actually simulation using Homer software in order, again, I'm still in Somalia, in order to find the system output in the north region of Somalia. What you can see in the table here, you can see some of the systems architecture. So what the software does, it will give you the best combination. So what your system should include in order for you to deliver electricity, and then it will rank them based on the COE. The COE means the cost of energy. So you can see here on the left of the table the architecture, which consists of this is solar panel, wind turbine, and this is battery. And this is generator. So this is normally a diesel generator, which is not environmentally friendly. So this is the ranking of the systems based on the cost, and you can clearly see that the best system we got was the one consisting of solar panel, wind turbine, and battery. And this system cost is $0.233 per kilowatt, and it is 100% renewable. So it has, as you can see here, 0 fuel consumption and 0 carbon footprint. But again, when you go down to other systems, you will notice that the second system will include a diesel generator, which will have some kind of carbon footprint. Going to the fourth case study with a company called BasketDrop. So BasketDrop is developing a unique smart delivery device. So just to explain it to you, assuming you made an order online and you are expecting the order to be delivered tomorrow at 9 a.m. This means you have to be in the home at 9 a.m. to receive the order. And normally in most of the conditions, you don't actually get it at that time. You have to wait for an hour or 2 or 3 in order to receive the item. So the idea of this project is to have a storage system. Maybe you can see can you see the photo here next to the car? So this is simply a box which is located outside the residential area. And this box will enable the delivery company to bring the product. And instead of delivering directly to you, it will be delivered and input inside this storage device. So it doesn't matter You are there, you are not there, you are busy, you are at work. It's not a problem, because when you come back to the house, simply you will have kind of application or a system where you'll receive a password. So once you are, there, you can just input the password to this device, and this, the device will open, and you can collect your item. And how this is sustainable product, if you think about it, if we have more than one delivery to the same area on the same day, so we have, various, drivers coming to the same area to deliver lots of products. What this technology enabled, it enabled the delivery company or the driver to deliver all the items of the day at one time. So they don't have to go back and come back because the other customer is more available, in the evening, and another customer is available in the morning. No, they can just deliver it at once. And at the customer, when the customer is available, they can just go to the storage and pick up their item. So we have delivered this prototype. You can see on the left, this is the 3D CAD modeling. And this is, the construction. So we made actually the actual device in the workshop, and this is the final prototype and how the prototype should look like. This actually will enable the company to apply for further funding to progress further with their project. And I'm going to the final case study of today. This is called VII Wall. This is a sustainable marketplace. This is like Amazon. But the difference between VII and Amazon, that VII does not accept any product to be sold in their platform. They are restricted. There are some requirements. In order for you to be able to sell your product on VII World platform, your product has to be sustainable. It has to be free of chemicals. It has to have low carbon footprint. It has to be made of recyclable and environmental friendly materials. Now, VII World came to us and said, this is our aim, but we need to have some kind of a tool in order for us to make a judgment, to say, does this product meet the sustainability requirements or not? So normally how they do it, they have a form, and the supplier or whoever want to sell their product, they need to fill up the form. And the form will ask the supplier a question: do you take sustainability into consideration when you make your product? That's it. So there is no evidence, because most of the supplier will just say, yes, I take it in consideration, but there is no evidence. So what we did, we developed two tools. The first tool will enable the supplier to input the information of their product. And from that information, we can estimate the carbon footprint of that product. And the other tool, very similar tool, you can see an example here. The other tool is more related to the water consumption. So does the product consume too much water to be made? So in this tool, you can see that we have different columns. So the first column, the supplier can select the main product, say wheat, for example, here. And then you will have the subcategory. So wheat, what type of wheat? So we made as much detailed as possible to this tool. So is it wheat bread? Is it the dry pasta? Is it wheat pellets? So the supplier will be able to fill up all this information, and this will give you the water consumption. You can see here, some of the data. This is just an example, because you will have three types of water. You'll have the green water, which is the rain water consumed, and then you'll have the blue water, and this is the groundwater, and finally you'll have the green water, which is the waste water. So this tool and the other carbon footprint tool will enable VII to make a judgment. Should we accept this product or not, based on the outcome? And the other benefit is for the customers. So as a customer, when you buy from Amazon or any marketplace, you will always have information that, you saved £5 today because you bought from us. This is exactly the same idea, but it's not related to how much you spend. It's related how much carbon you have saved, how much water you have saved. So if you bought a t-shirt through their marketplace, you will have in the dashboard some information on how much you have saved using this t-shirt in comparison with a traditional t-shirt outside this marketplace. So this is something also useful for the customer to track their sustainability performance when they do online shopping. Again, this is the website, www.svi.business. So if you are more curious, because I have only included 5 case studies, but we do have much more than that. We do have more details on the kind of support we provide to businesses. So if you want to, to discover more, you can go to the website and find much more case studies of my colleagues as well, who are working in different areas like electrical engineering and other areas as well. Thank you so much for listening, and I give it back to you, Dr. Moin.
First question goes to Abdulla. I think very interesting presentation on startups and also linking innovations with youngsters and linking with African countries and all. So I think these kind of projects always have a lot of challenges actually. So I would like to know what kind of challenges you experienced handling such startup companies, also handling this kind of projects. And to
Go ahead then.
Yes, doctor.
Okay, thank you for the question. So let me talk about challenges from our side and London South Bank University, and also challenges that faced by the SMEs themselves. So from our side is that because sustainable innovation is not limited to a specific sector or school. So we receive applications in all the sectors, in all the areas, sometimes related to chemical engineering, sometimes related to artificial intelligence, machine learning, mechanical, material science. So one of the challenges is trying to find the right academic or expertise and connect them to that project, because some of the academics, we may have them already, but probably sometimes they're so busy with their teaching, with the research and this sort of things. So I would say probably one of the main challenges for us is that we are not limiting the area of support to a specific sector. But I would say probably not more than 90% of the applications we have received, we managed to sort this kind of problems out. So this is a kind of small problem. The other thing is the time frame that or the resources we offer to SMEs. Sustainable innovation aims to help as many SMEs as possible. So in each cohort, each cohort is 6 months, and in each 6 months we support, let's say, deliver 15 projects. So because we are delivering high number of projects, some SMEs come to us and say, we want this amount of support, but we try to convince them that we are limited on the resources regarding the time of the staff, and also the budget and this sort of things. So we try to provide the maximum amount of support useful for the company, but with the lowest resources. Regarding the businesses themselves, I would say, because we normally help them in the technical part of the project, some businesses come and say, I understand the technical part. What about the business part? How I do the marketing, how I actually get funding, but sustainable innovation is more relevant to the technical side of the project rather than the business side of the project. But we do actually, for the business side, refer them to the right people in the university to provide them some support. But I would say the business support is normally limited, but most of the support is more related to the technical part.
One question from Dr. I would like to ask question to Dr. Qaban. So basically, you are handling a lot of startup companies, and they are applying to your program, and you are connecting those people, those who are providing you a proposal, with some of the experts. My question is that we as researchers, we are all experts in our respective field. Why is it that we are not the one? Is it that we are the one who are proposing startup companies, or is it otherwise that those who are like juniors, or those who are in other fields, those who are not researchers, they are proposing startup companies? So why is it that the researchers at lecturer level, associate professor level, professor level, they are also not initiating a startup company, knowing that they have the expertise? What we do lack, what are we lacking when we compare ourselves to those who take the initiative to make a startup. What is the difference between those who take the startup, those who initiate a project, and us? What is the difference between them and us? Why we are not basically going for this startup initiative, knowing that we have these skills, we know where is the solar concentration, we know where is the wind energy concentrated, this and that. So this is my question here.
Thank you, Doctor. It is actually an interesting question. If we, as academics, we are supporting SMEs in order to develop their products and commercialize the product and give them much support to progress from the idea stage into the MVP, into the final product, into the commercialization stage. If we are unable to help them to do that, why don't we do that with ourselves? I think one of the things is how people would like to proceed with their career. Normally, jobs are more secured. So if you have a full-time job, daily job from 9 to 5, and you are already, doing what the job requiring you are fully, matching the responsibilities and conducting the work that you are required to do, you are met the expectations of the job. When it comes to business, there are some statistics that says around 70% of businesses fail. This is a big percentage. That means around 1/3 of the businesses actually exceed. And I would say probably what I have noticed from dealing with CEO of businesses, that they are always under some kind of pressure. The businesses the CEO who already have full-time job, they have less time for their business. And when they have less time for their business, there is more opportunity that the business will not be able to achieve the objectives. So I know some people who left their job and they just, focused on establishing their business, because they realized that, if you want to start up a business, you cannot just do it as a part-time. It has to be something that you allocate most of your time for it. So what I would say, the main thing probably would be the time. Not many people are brave enough to leave their job and go to start up business if there is a chance that this business will fail in the future. So what I would think probably the main reason is that a kind of people are more looking for secure job rather than taking some risk in going for business that it could have good opportunity to to achieve the goal, and you can make a very good, actually outstanding project, but in the same time the risk is high. So it seems that most people, including academics, not only academics, even people who work in companies, or people who work in companies, they have full-time job, but they don't have their own business, and they have the kind of consultancy jobs to help SMEs to support them with their product development. But in the same time, although they are really expertise, they are very good at what they are doing. They are specialized. They may work in the research and development as project managers. But at the same time, this kind of mindset that leaving a job, secure job, and going to a business where you cannot predict the market, because when you talk about business, there are many things or parameters that could affect it. It is not only the idea, it is the funding. You need to get funding for it, which is not easy. It's very challenging. You apply for funding where you have 10% opportunity to get that funding. So you have 90% chance you don't actually get this funding from investors, from the government, and so on. The other challenges could be technical. The other challenges could be attracting people to buy your products, for example. But I would say one more thing, actually. Normally, you would be specialized in a specific area, for example, as a mechanical engineer, but I would need to build a team with me. So as a mechanical engineer, I will not be able to have a complete business. I need someone specialized in marketing. I need someone specialized in business. I need someone specialized in it could be other areas in my product. So even if I'm mechanical engineer, I need someone who's specialized in electrical engineering to solve some problems related to this product. And it may not be easy to find these people and to gather the team together. It's not easy to employ them because you don't have a kind of resources to employ people. So again, there are lots of difficulties, but I would say people should be encouraged actually to start thinking or to change their mindset in order to develop their own ideas and turn that into reality, into something in the market. And I cannot tell you how many businesses I have looked at and how successful they are. And there is one example, one professor in City University of London who invented a flywheel for electric cars. So this flywheel will be able, the owner of the electric vehicle to charge his vehicle in 2 minutes to be able to travel 100 miles. So he was still an academic, and they got a really good funding. They got $500,000 from Innovate UK. They got £2 million from investors through Crowdcube, and he left the university now recently, and now he's leading that company. It's a very successful project. So there are some examples, and I think, yes, it's a very, very good question that open our minds and thoughts in order to break the comfort zone we are, surrounded, and try to, generate ideas and innovate and go, outside our normal job and make something useful for the society and environment.
Thank you so much for your detailed answer.